So after consulting with AI and just trying to figure out what really to do, the main component U1, the large BGA chip, is really my only culprit. I don't want to remove that chip if I don't have to. So I need to fully, I need to exclude the main Wi-Fi connector as part of the problem. Like, in my efforts to reflow it, did I accidentally bridge a connection to another IC? And that IC is not expecting 1.8 volts, and it's just sort of freaking out when it becomes under power, or just immediately shorts the ground as just sort of like a failsafe. That almost seems a little too grandiose, but that's really my only choice that isn't reworking an entire BGA chip with several solder balls that will take hours to reball by hand because I don't have a stencil. And that's assuming that I even have solder balls that will work. So what I'm going to do, as I'm kind of prepping to do, is I'm going to remove the connector and then put power into the board. And if the board still shorts, then it was never the connector. So then it has to be U1, based on everything that I know. Which admittedly isn't that much, but this is really my best option. The best I can do. What I might do is try to remove it off a junker board and just see kind of what happens. Like, I'm kind of worried about it just removing a connection altogether, and then when I try and test a short across the rail, I just get nothing. So then it's like, well, I don't know if that actually fixed anything. So what I need to do now is just I need to eliminate this connector as a problem. Because if it is a short underneath the connector, like maybe I melted it when I tried heating it up the first time, or maybe when I shifted it, like maybe it went from a bad solder joint to now me bridging a solder joint, and just the luck of the draw, it's displaying the same problem. I really won't know until I do this, I think. Because this will exonerate the connector as a problem if I take it off and then put power into the board. Exonerate meaning that it was never a problem to begin with. I'm betting when I pull this off, though, the underside is just going to be melted. Getting close. Okay. It actually didn't. I just have experience working on thumbsticks. And when you're melting from the back, you just melt the underside of the connector. Or you melt the underside of the joysticks and it just turns into a plastic goo. But I guess these plastics are a little more resilient. I do want to look at these traces, like especially up here. I did not scratch away that solder mask. I did for the ones down there, but I need to make sure, just kind of look at those connectors and see what they look like. Let it cool down. What I can do is test for a short. Right now it shouldn't read anything. It should read the 2.6 kiloohms. That's what it was before I started this. I checked it before I started. It's back to normal. The flux might not be giving me a good connection. Okay, yeah, that's about right. I don't think it needs to be exactly 2.6 kilo ohms, but it is in the 2 kilo ohm range. I can try it again when I clean off the connector. I just have to let it cool down. This poor board is having one hell of a surgery day. I know a lot of my flux, especially right in there, is just solidified and just turned into goo. And when it turns into goo like that, it almost never comes off. Like eventually I can sort of flush it with enough IPA, it sort of comes off on its own, but still have. Yeah, I don't remember removing the solder mask up there near that pin, up near that resistor. I know I scratched away that solder mask because the pins looked really dark. Just make sure I get this area nice and as clean as I can, at least. Even though I am going to be applying flux to get the connector back on, I just want to get it to a state. I don't think my flux is conductive, but that's not something I want to try. Well, if anything, the connector pins look great. Like, I really can't find anything wrong, like, mechanically speaking. I don't see any, like, trace cuts. I'll keep sort of cleaning it here. Like, even those pins I thought were kind of suspect look fine. I don't know why there's maybe just a little bit of corrosion on top. I can check why. I don't know why that's exposed copper right there. It's very strange. Let me just check this pin then. It's connecting, so, I don't know. It must have just flaked off when I heated it, maybe when I was running my irons over it. Okay, well now I have to do the fun job of putting power into this. I know this cluster area still looks really gross, but I don't really think there's much I can do about it. I brushed it as best as I could, but I think there's just nooks and crannies I can't really get at. Shouldn't harm anything, it's more just cosmetic than anything. But if it looks nice, I feel better. Just shaking it to try and get the water, not water, but rubbing alcohol off. So now I'm going to put power into it and just, if the short persists, it wasn't the connector isn't bridging. It has to be the BGA chip. Which I really don't know what the console's going to do without the main IC. Will I be able to even put power into it, or will it like go into like a panic mode and just not allow power into the board to begin with. Which, if it doesn't allow power into the board, I really can't prove what was wrong. Alright, so let me check the capacitor one more time. Get a reading. Just for absolute certainty that the reading I have right now and the reading after I power the board is different. .7 kiloohms, which is about what I was used to seeing. Alright, let's put power into the board. I'll just have the little blue light. Blue light, it's behaving as though the Wi-Fi board's not plugged in, so I'm holding the power button to force shut it off. Please be the connector. I would very much be pleased if it was just a connector and not a full short under the main IC. Curious. So it isn't immediately shorting to ground. Let me actually touch a ground plane. But what? That might be my culprit. It was the connector. Huh. That is curious. Okay, let me put the connector back on. Or these connectors are really simple. Like, I think the issue I was having is it is just a really simple connector. There's nothing too crazy about it. The only thing would be is if it had a bridge underneath it. Doesn't look like it. And I think these connectors are kind of, doesn't matter what side. They're a bit ambidextrous. Okay, I need to sanity check this again. It's not a full short. Well, it's 15 kiloohms. Let me power up a good board and see what the resistance is. I think that's normal. That it's not... Was I reading 2.6 kiloohms correctly? Now I'm going through a self-doubt here. I connect my good board, put power into it, and then read the... Well, I won't go that far quite yet. Let me read the resistance on this capacitor first. Good board has not been powered yet. So I think I said 2.6 kiloohms, but it was 27 kiloohms. Okay, 27 kiloohms. That was just a decimal error. I don't think the value itself really matters. It's the vast difference between the two. Yeah, this power board ribbon cable is a little bent up, so it doesn't like to go in the connector without a little bit of force. not an issue, it's just a little different. Have to sort of plug it in slightly different than what I'm used to. Okay. Blue. Holding it to shut it off because it doesn't have a Wi-Fi board plugged in. Now let's read the resistance again. Across capacitor 59. What? You're telling me that's normal? And I was chasing a... The short's going away extremely fast. Huh? Now I am going crazy. Okay, so that short was normal. It just goes away really quickly. Okay. So it's short. I don't know exactly what that tells me. But what it is telling me is that that short is normal, which was why the console was pretty much, relatively speaking, like, functional. But the short wasn't going away on this board. So let me test it again. This is unpowered, but it was powered. It's kind of wild. I wonder why I didn't test that short before. Guessing it'll go up to 27. Right now it's at 15 kilo ohms. Let me check the good board again. So the short's going away a lot quicker than it was, but not as fast as a good board. Right now it's at 27 kilo ohms. Or it'll probably go up to 28. So it's still behaving differently. It might be because that capacitor is there. $15. I should probably put that capacitor back. Just to see if that changes anything. Before I go ahead and put the plug back. It'll be a lot easier to put it in. Well, it actually might be a little more difficult. I don't know what to make of all this. Wow, that was smooth. Huh. I won't complain. So the capacitor is back, and I know this capacitor is good. At least it's not, like, obviously faulty. I don't know if it's good or not. as far as like normal capacitor, a normal capacitor 59. But it's not like, oh yeah, this thing is completely blown through or something. Otherwise, like yeah, it behaves normally. But let me see what I get now. Is it the same? So I'm still at 15 kiloohms. They're really kind of perplexing. So it's not really on screen here. But it's not a full short, nor is it hanging on a full short. Yeah, it jumps down to about 15-ish. Which again, my good board doesn't do that. Both of these were powered recently. Oh? No, this one goes back up to 27. I guess I can put the connector. I almost don't want to put the connector back on without it being like finding out like what exactly the problem was. Because I don't know. I don't really want to hand solder it because that's kind of a pain. And I would definitely melt this connector more than I have. And it makes no logical sense for this to be the connector because it's just, look how simple it is. Hmm. Getting everything lined up will be kind of a interesting job. Gotta kind of put flux around it so I can try and get something without bumping it. Like that. And yeah, I'll put it back on and see what happens. Nothing ventured, as they say. This isn't going well. I don't know how well that went back on. Well, looks like I did okay. I can check them, but I think that did okay. Oof. I'm not scorching the board, but what I think's happening is solder flux is getting around to the backside and it's just like boiling off. That's what I started smelling. Either that or the connector is starting to melt. I am hitting it with quite a bit of heat. So if it's my negligence that kills this board, then whoops. It's flowing through the vias. Shouldn't impact anything. I was heating it for a very long time, but I don't know, it looks fine from the top. But I was smelling kind of burning plastic. It's a little hard to say what the smell is. take a look at this side again. Yeah, I don't really know what I burnt on this side. Uh-oh. Did I burn solder mask? I didn't even think I could do that. Get a real close up on that. I'll try not to pick away too much of this, but now I kind of have to know what's under here. I didn't think I could melt solder mask. It looks fine. Yeah, I thought it was just maybe plastic bubbling through the via. Or plastic or flux bubbling through the via. Either way, I will choose to ignore that for now. Hold on, voltmeter. I still need you. So let's test the capacitor again. Now that it's in circuit. Again. We're still at about 15 kilo ohms. Let me put power to the board. Okay, got the blue light. Just shutting it off now. Check the capacitor again. So it should read a short, but okay, there it is again, 80 ohm short. So does that prove it's the connector? That doesn't make any sense. Assuming this connector is on, even. That all those solder points flowed. I never really checked that, did I? According to some random probing, here's my bare copper. So far it's all shorting correctly. Nothing's jiggling when I'm pushing on them. Oh, 2, 4, 6, 8, 10, 12. Should also be shortened through as well. 2, 4, 6, 8, 10, 12. I almost have to remove it again to confirm it. Now I feel like I'm going crazy. Why would it be a connector? That doesn't make any sense. What happens if I plug the Wi-Fi board in? Does that change it? Not at all, it just hangs open. Let me first get a little fan going. Whatever I burnt is pretty strong. Let me look back at my VOD and just see kind of what I was seeing. So when I took the connector off, when I went to measure the pad for that capacitor, I remember kind of being difficult. This is after the connector was removed. I got actually 2.8 kilo ohms. Looks like I'm trying again. Okay, I'm cleaning it. Drying it. Yeah, I actually got 2.7 kilo ohms. So it wasn't 27. Huh. Did I power it up? Yes, I did. And then when I went to test the points, I wasn't getting an immediate short. I got 15 kilo ohms. So that connector's creating a short. Well, that doesn't make any sense. These connectors shouldn't be bridging points. Not at all. It's not their point. They're not doing anything. They're just taking... Color me a bit perplexed. Right now it's still shorted. Well, I suppose what I could do is replace it with a donor. I guess. I'll take it off again and just see if that short still persists. Because that seems as extremely unlikely as it seems. That's like my only real culprit. And I can see if I actually melted it. I think maybe the problem I had when I was putting it on is I used too much flux to think there would ever be such a thing. Almost there. It is now off, obviously. Let's check the resistance again. I wonder if there's just like thermodynamics at play, and because the board is hot. Because it's not a short. So right now it's not shorting. I am going to let it cool down. Again. So why is the connector creating a short? That sort of defies everything that I understand. Unless it's bridging the ground, which it shouldn't be. Where on earth would it be grabbing the ground plane? And the connector can't be faulty. That doesn't make any sense. Again, the connector is really simple. Like, I guess maybe the only thing I can think of is maybe a pin inside is bent? I really don't, I really can't rationalize why this is happening. Let me just really inspect this connector. This makes no sense. This can't be a cause. Because there's nothing wrong with it. It's simple. But it isn't simple. I'm wondering if it's something that I did back here, if just cooking these... Like, I don't even know how this happened. Should probably scratch all that away and just see exactly what's going on. It was kind of bothering me, like, what the hell happened here? Like, I melted some of the... Oh, there goes that trace. Like, I melted, like, an inner part of the board. My question is, how on earth did that little part of the board get so... Not how did it get so hot, but why did it melt like that? It almost kind of looks like some of the silk screen is... I don't know if it's bubbling up. But it like delaminated the trace. Like that's completely gone. Ooh. Yeah, yeah, I may have just killed this board then. So what I think happened, it's hard to say with my magnifying, but I'm looking at it. I increased the I increased my view of it. And it looks like I just completely heated up and broke through the layer. Like there's a trace right there I just picked off. I don't know why that happened. But it looks like I did sort of melt the PCB. I didn't even think I could do that. So whatever those vias went to are just completely just melted away. Literally melted away. So I never proved the fault. I really don't know what was wrong, but I don't think I can do anything with this board now. Like I could try and repair these traces. To what end though? Like I don't know if I have... Do I even have wire that thin? No. I don't have trace wire that thin. It begs the question, I wouldn't know what to do with this board. Even if I did get it, like, back. I don't know where that short was, aside from reflowing the U1 chip, which is this big CPU. So, that sucks. I guess I put a little too much heat into it when I tried to put that connector back on, but damn. Well, I'm sorry, motherboard, I didn't mean to kill you, but considering what I had to do to even just get the charger back going, if I had to make a bold assumption, corrosion. Hopefully it's not the main chip. Maybe, I wonder if, since I'm junking this board, I might as well see what happens if I remove the main chip. At this point, it doesn't really matter. So I took the connector off and then suddenly the short went away. Well, what's odd is I get like a few different readings. So now I'm at 15 kilo ohms. I've had 2.7 kiloohms. So I'll see if it will power. I don't know what those little traces went to. I mean, that trace cluster is right underneath the main CPU, so yeah, there's nothing I can do with this board now. I fried it. Quite literally. So blue light. So here's the short again. So then that proves that wasn't the connector. Let's get that main big chip off. See what happens. Nothing. Science this, baby. At least now I won't have to put back on all of those other components. So there's a positive and a negative. I think my problem, where I got in trouble is I put way too much flux on. So when the flux was liquefying, it was like keeping the connector physically off the board. So with the connector being physically off the board, I had to sort of wait for it to liquefy. And wait. And wait. And just cooked the board. So now, let's make even more smells. I haven't taken off this chip before, so this should be kind of fun. It's a big BGA chip, so it'll take a little bit to get going. Some of those balls being bridged might create inconsistent results. Right now I'm at 1.7 kiloohm resistance on the... I actually might have solder balls that small. But what I want to do is try and wick off those bridges. Actually, these solder balls are pretty big. I guess I didn't need to wick them off, I just had to run my iron and collect them all. So to speak, collect them all. That's what the... I'm currently trying to measure resistance on it, and it's giving me a really weird reading. No, 2.8. Okay, it was in the mega ohms when I was first probing it. I'm like, what the heck? I actually don't know what's going to happen if I try putting power to this thing, but it shouldn't kill any other components. So that main CPU might be faulty. It's hard to say what the problem actually was. Well, if corrosion ate away at the charging circuit, it stands to reason corrosion is the problem causing this additional problem. And I was never able to sort of prove what it was. I just got really strange behavior kind of throughout. Like, that connector shouldn't... Like, desoldering that connector shouldn't have created the results that it did, unless thermodynamics is kind of at play and sort of the physics of circuit boards and when heated behave differently. I guess I'll never know. Alright, it's still... I still get a blue light. For what it's worth. Oh, well, it went out, but... So if under normal circumstances, it should still short, but it rapidly goes back to normal. Which it isn't really. So no, it wasn't the U1 chip. Then I have no idea. I have no idea why it's behaving like this. No, maybe, because now it's not shorting. Traditionally shorting. Ground side shorting, but the positive side isn't. Like, now my readings are just kind of all over the place. Diode. Like, now it is going back, so maybe it was U1 chip. Yeah, yeah, I don't know. The U1 chip was sort of the only culprit. Why I was getting kind of strange behavior when I took the connector off, I have no clue. But I'm gonna have to just assume that the U1 chip is faulty. I'll keep it. because I can't actually like prove that it was the U1 chip. Like unless I try and like look underneath it and see if I find a short underneath one of these or on one of these balls, if I can find the rails. I don't know if I can. I think I kind of know where they're at. I'm gonna have to look at my board schematic again here. This one. This is the one I'm looking for. Yeah. Okay. So oh yeah, just look at all of those V18 and V30. Like which one of these possibly shorted the ground? Like there's just a ton of them. Oh boy, like how crazy do I want to get here? Do I want to start probing to see if I can find a short from if there's like a cluster of shorts? That would at least prove it, like beyond a shadow of a doubt, that there's something wrong with this chip. That it's not just me just jumping at shadows, so to speak. Because that's kind of where I'm at right now. I'm just like jumping at shadows. Let me see how it's oriented. So it's oriented like this on the board. Which I think this is a... So if I wanted to get sort of a backwards perspective, the chip is pointing that way. What I could do is like take a screenshot and sort of inverse it. And just kind of clean it off a little. Because I would really like to prove this to be faulty if it were the point. Because then this motherboard did not die in vain. This is going to be really hard to test. Okay, so it faces like this on the motherboard. So the current picture I'm looking at is what it looks like right underneath this thing. Screenshot it, blast it into paint, and then flip it horizontally. It's going to be kind of hard to read, but it should give me everything that I need. Okay, so now it's going to be counting balls. It's oriented like this, and I flipped it. But it only shorts under power. I don't think I'm going to even if I can try and find a short, I don't think I'm going to be able to without injecting voltage into this, which is not possible in my current setup. But a little disappointing. So it's 5 and then 5 over. So 1, 2, 3, 4, 5. 1, 2, 5 by 5. 1, 2, 3, 4, 5. That's a 3.3 node, or 3.3 ball. So is this one. Or maybe they don't connect internally in the chip. This is just the traces underneath the chip. So yeah, I don't think I can do anything about this chip. I'm just gonna have to say that it's possibly faulty. I don't think there's much I can do. Well, what a disappointing end to this saga. I did what I could, but I cooked it, literally. Well, shit. So now I have a junk board, which probably for the better. I wasn't so much disappointed in this trace work, or in my trace repair right there, but if there was enough corrosion to damage the motherboard to the point of separating a via from the positive plane of the battery connector, what's to say there isn't corrosion somewhere else creating my issue? I didn't notice anything. I tried grabbing at everything that I thought was suspicious, but it wasn't enough apparently. And something else was wrong. So I don't know if it was a chip. None of these chips were behaving wrong. Like even the main chip might even be fine. Unfortunately, this board is now junk. U1, this one should be fairly obvious. This is the U1 chip. I think for the little bit of time I have left, I'll look at another console that has a charging issue, one that I'm apparently far more competent at fixing. For now, I just want to sort of categorize all of these. It's the P5 connector, it should be pretty obvious. But I'm just making sure I have these, as these are, as far as I'm concerned, functional spares. I want to make sure I get all these little tiny chips. This one is U8, this really tiny one that I pulled off. U8. Because I have a little parts area that I have, a little parts container. Since these components are probably otherwise functional, keep them just in case I run across one that isn't. This is U7. And finally, we have the main sound chip, which is the U4. Not doing anything too crazy when it comes to sort of categorizing these, just taping them to a sticky note. U4. So I think in conclusion, that an error can occur when opening up programs. The cause of that in this case was unknown. It sort of circumvented all of my usual problem solving. I need to grab the documentation I have on this board and just relegate it to junk. Which one do I have? XL, motherboards, US needs repairs. This one is 0511. I think it's this guy right here. 0511 6012 U01E08S A1. I'm a little, feelings on that is a little complicated. I'm a little sad that I have to junk this board, but I think it's just for the best. Alright, let me sort of get things back together here. Alright, so now we get back to a board. Unknown charge port issue. What does that mean exactly? Well, in my way of describing this issue, it is a single charge light flash. I'm looking at the usual culprit, however, and it looks fine. Ooh, never mind. I'll get to that in a second. So first, I have the power board in. I'm just going to plug the charger in. I won't spoil the surprise. Let's say. So right now I have a USB tester in. It's not going to show a pole because there's no battery to charge. So plug in the charger and we actually get nothing on the power light. Oh, this charge port feels very loose though. Oh? Appears to be fine. So I'm getting no charge light at all. The charge port feels very, like, loose, but the charge port itself felt fine when I was sort of digging the charger in it. So now I'm going to check the fuse. There's a small surface-mounted fuse. I guess I can get my microscope back. Just right downstream of the charge port. That little fella right there. I'm getting continuity through it, so the fuse is fine. I wonder if I'm detecting any voltage through this connector, because I'm not getting a charge light. Oh, it might be because I don't have this power board in connected all the way. Like I said, this power board little connector end is a little bent, so it doesn't go in all the way. At least not, it sort of contradicts my muscle memory. Oh, there we go. Okay, so I just didn't have the power board ribbon in all the way. Anyway, as you saw, it only flashed once. So now let's get it into a shell with the battery. Let's see what it does. Have the little USB tester right there. On, then off. It doesn't pull a charge. Now, when I was saying there was a usual culprit, let's go to what it's supposed to look like. So, between the positive battery connector, there should be a direct line to this IC right there, component U11. I understand this to be sort of the main chip responsible for charging the console. So if there's something wrong with it or something wrong with the pathing to it, then it's not going to charge the battery. Currently on continuity, so it'll beep when I have continuous circuit. So between the positive battery connector to these two pins on the end of U11, which are pin 9 and pin 10, there should be a complete connection. So I'll even connect to the positive on the battery board. There's nothing. There should be an uninterrupted line from the positive to this point and to the side of the capacitor as well. So now I'm just going to kind of hopscotch my way over. I'm going to go from the positive on the battery, the actual battery connector, to the positive on this connector, just to see if I have continuity through the cable. There's nothing wrong with the power board. There isn't. So now I'll go from the positive here to the back of the connector, board side. So that means both the male plug and the little mounting point are good. So from the power board to the connection on the motherboard, it's all good. I'll remove my sticky note. So now let's come down here. I'm going to go from the positive right here, which is sort of the underside of the battery connector, to test point 7, which opposite to this on the other side of the board is the connector. The positive connector goes into this little cluster of vias and then spits out right here. It also connects to an inner positive plane in the center of the board, which goes sort of other places which aren't important at the moment. So from the positive to here, I should have a connection. Which I do. I'm kind of having a rough connection with the power board, but I have a full connection from TP7 to the positive. So from test point 7, I should pick up the positive connection all the way up here, right on that little disgusting little butthole of a via. This fella right here. So from TP7, I should be getting a full connection into this via. Which I am, which is a good thing. So now, what I'm going to do is go from TP7. Well, I'll take a step back here. So from this via, it goes across this plane all the way to those two vias right there. So I'm going to go from TP7 to these two vias. I need to expose a little bit of copper. That should be enough, and nothing. So, what might the cause be, I wonder? Corrosion. How? No clue. But this is the third or fourth time I've seen this. Right here, exactly. Now this test point down here being a little crummy, I'm not worried about, but for some reason, this via isn't connecting to this plane. So what I need to do is scratch away some of the solder mask. And try and see if I can get a connection to that via. Usually what that means is I have to feed a wire into this hole, solder the wire, just sort of make my own via. We'll see. This is similar to the problem on that other board, but in that case I couldn't get a connection from test point 7 into this via like I can this one, so I had to run a jumper because it was so corroded that it wasn't making a connection to the inner layer of the board. I'm going to try and just sort of, I can flick away a little corrosion, if there's any at all. My best theory as to why this happens is this is right at the edge of the bottom screen. So if there was any water damage or any sort of fluid that got onto the bottom screen, it sort of wicks away right into this via. Just sort of the perfect storm. Okay, so now let's look at it again. So from test point 7 to this via, the inner part of the via, I should be getting a connection. Which I might have to kind of fish around in there. I am. So, but from test point 7 to this raw copper, nothing. So that via isn't connecting to this plane due to it just being corroded away. So what I will try is to just see if I can just get some solder that goes into there. Flux it up. I'll see if solder will flow into there and connect the via to the pad, just with solder. In the few times I've tried this, it doesn't work. But that's all just based on state of decay, so to speak, of how much the corrosion ate away. Let me get my... Okay, well, that usually doesn't work. Usually what I've noticed is the solder just sort of bubbles on the top, leaving a sort of void where it doesn't go into the via. So from test point 7, I'm going to touch the blob. And I get nothing, so I need to feed a wire through it. What's interesting is if you inspect the other side, that via looks good. So it's just on this side, which really leads me to believe that it is due to just moisture damage off the bottom screen. So I have this gauge wire, which is sort of perfectly thick enough to fit in that via. I need something to grab it on. The wire gets very hot. There we go. That's what I like to see. Need a little more flux on it. Alright, let me flip it over. Got my wire poking out the via. And ideally I want to put a little bit of solder on this side as well. Just so that that wire doesn't move around. Thought I saw enough copper to maybe do a connection. I'm gonna flush cut it. As you can kind of tell, I haven't quite mastered this, but I at least know the cause. Let's try it again. Actually might be a little better than I thought. That looks better. I like that. So now what I'm essentially doing is just rebuilding the trace. I actually don't think that made a connection to the via. It looks like it grabbed it on just a little bit. It doesn't need to be rock solid. Just enough that it's connected. I'm basically taking that that internal connection that I had and bringing it back externally where it belongs. Okay, so let's go back to here. If everything did what I expected it to do, I should now have continuity between test point 7 and my solder blob. I do. And now I should have continuity between test point 7, where am I on my camera? All the way into these two vias right here. I can try and see if I can, which I do. So I've restored continuity to that rail all the way up to component U11. Let me snip these off, or snip off this wire. And then I'll run another cotton swab over it with rubbing alcohol. I don't think that test point right there is all that critical. It doesn't look that bad. Right. I didn't check to see if this thing booted. Probably does. This circuit trace that I'm working on has really nothing to do with the console's ability to turn on. Well, actually, it doesn't have anything other than just the ability to charge the battery. But now, so let's go back to U11. I should have full continuity between the positive on this battery board to these two legs right here. Which I do. Oh, what does that mean? Well, let's get the console back together. At least the part's important for it to charge. I have the battery in. And now when I go to charge it, solid orange light, and I have an amp draw. If I were to unplug the battery, instead of a single flashing charge light, I now get a blinking charge light, which is how it's supposed to behave. Perfect. So what I'm going to do is get a little bit of Kapton tape to cover over my little solder blobs that I made, just so they don't cause any problems. Nothing too crazy, just a little bit of tape. Now I'm going to put it together enough to test, because I never actually did that beforehand. I would have probably left more detailed notes if the thing didn't turn on. Just that the fact that it doesn't charge is sort of all I left. That usually means everything else is fine. Or that any other problem wasn't as pressing. Okay, I can't plug in the touchscreen. I should probably just get another bottom screen so I can wipe this device. This does not have a Wi-Fi board in it. I shall put one in. the battery. I'm not getting any response on this touchscreen. I'm guessing it's also bad. But console seems to power up and do everything it needs to, so. And it also charges. Yeah, I don't know what's wrong with this touchscreen, but it's part of my tester boards. But as far as this console is concerned, it is fixed until further testing. So let me just remove all my components, and then I need to update my information I have on this console. This is that board. This is 50515. 1590612 LA39. All right. Repaired unknown charge port issue. Single charge. Blink with no charge. Fixed by repairing corroded via on battery plus plane. Sort of what I'll unceremoniously call it. And then just put no known issues. Well, fantastic. That went a little faster than I expected. I think I got time for another one. So that board will go into service, essentially. And look at this. I have another unknown charge port issue. And would you look at that? That via looks awful. I wonder what the cause is. Couldn't be that via again. Let me start by just doing my full diagnosis of the charge circuit. Let me get my power board plugged in. Fully this time. Okay, I guess I can highlight the orange light. I mean, why not? Battery is not in, so let's plug in the charging cable connected to my little USB tester. So I think it flashed there because the connection to the charge port isn't good. Maybe it just needs to be reflown, or maybe just when I was plugging it in, it was kind of skipping. But yes. Oh, kind of like that. So when I plug it in, charge light on, charge light off. We put the battery in. Same problem, no power draw. So now I will kind of quickly go through the normal path from the battery plus up to U11. But just kind of based on what that via looked like, I'm going to make a bold assumption it's that via again. Okay, positive to the battery connector, to the board. I'll drop the thing. Didn't break anything, it looks like. Just make sure I didn't break anything by dropping it. Nope. Okay, from here to here. Sometimes I kind of get I'm not getting a connection to test point 7. I've also noticed that sometimes corrosion goes into test point 7. So I don't think I can really use test point. I'll just kind of show it. I think when, I don't know, and also probably just a convenient amount of corrosion. Doesn't look like it's breaking that line, but I think because it narrows right there in between the vias and the test point, that the connection might break if there's too much corrosion. Ooh, yeah, you can see that perfectly split line. So let me expose the vias, because those are the ones that are important. The test point's more just for convenience, if anything. I've seen this too. I don't usually bother with it too much, but yeah, there's a clear break. I'm getting nothing, so I'm going to ignore it for now. I'll deal with it in a little bit. So I'm going to go from the vias, not the test point, but functionally the same thing, up to my troublesome via. I am getting connection in the via. That is that guy right there, which still looks gross. Let me cycle on over to those two vias. Try and pick off a little bit of solder mask just so I can get some exposed copper. There's just a little bit. Yep, and from the via to those points, I'm getting nothing. So, this is exactly like it was. It's exactly the problem I had just a little bit ago. Like, once is a coincidence, but... Or once is, like, interesting, but... Or I don't even know what I'm trying to say. For it to happen once is one thing. For it to happen, I think this is 5 times. That's a pattern. One surmises. So what I'm going to do just to kind of restore the functionality of this test point is I'm just going to goober on some solder and just bridge this point. Like that. Just in case that test point has any sort of relevance to underlying board layers. This just covers my tracks, essentially. Let me check from the positive line to this solder blob. And we're good. So now I need to focus on this via once again. So I was getting a connection inside the via, which is good. So I won't have to run a jumper. But like before, I need to sort of chip away some of the solder mask around the via. And I will try the solder blob. I don't think I've ever had that work on me before, but it's always worth a shot, I think. Okay. Just to confirm it's the via, I'm going to go from a newly minted test point 7 to the copper surrounding the via. And I'm getting nothing. So I'm getting continuity actually pretty far up in this via. I might actually be able to get it with just a blob of solder. A lot higher than I'm used to, so this corrosion's not as bad. Let's just say this would be a really nice fix if it was just that. Heated it up pretty good. I'm not very hopeful, but... So from test point 7 to my little solder blob right here. Nope. So I'm gonna need the wire again. Well, it was worth a shot. Just sort of getting it in my hands correctly. I don't think I have it. The angle's doing me any favors. There we go. That's what I want to see. I'll get a little more flux on. There's my wire poking out. I think I will start to just flush cut them. And then just try and solder to the top of the little pimple. Because similar to that other one, that via looks pretty good. Oh no, solder on the run. Let me get the power board out of the way. Some flux. Sort of shoving the wire down in there, actually. There. That's what I want to see. My little solder pimple. Okay, so now I should be getting continuity from my test point 7 up to my VIA. Which I am. So now from my VIA up to the little scratched copper I have over here. Which I am. So now, plugging the power board back in. Completely. I should get full continuity from the battery positive up to those two legs, leg 9 and 10 of U11. Will be these two right here. And I now get full continuity. So, like before, let's go without the battery first. Instead of one single blink, I get a steady blinking charge light. With the battery inserted. Steady charge light, amp draw. So that circuit is repaired. Interesting how it's always that via that goes bad. Again, my assumption is that's right at the edge of the bottom screen connector. So then what's happening is if there's any water damage that happens or anything spilt on the console, it would wrap around the screen and then sort of deposit right there. There's just a little bit of flux on this Wi-Fi board, because this is the Wi-Fi board I've been using pretty much as my tester board. So it just feels a little gummy when I was putting it in. I didn't put the Kapton tape on. I'll do that after. Shouldn't harm anything right now. Hey, this touchscreen works. How about that? Not really. These are tester components for a reason. Goes into settings just fine. Oh. Okay. Probably not supposed to do that. I won't be able to wipe it with this setup. But I did get it repaired. No known issues beyond just that little bit of testing. Oh, aside from, you know, this thing needs a charge port. I didn't catch that. So those prongs must have just had enough resistance in them to charge. So good prongs. Obviously, that is not good. I don't think I have enough time to fix that. Oh, and you know, if I would have read my note, it says charge port. So I will throw that in the list of what I need to repair. This is just a charge port. That I can do later. Those are relatively easy. I'm just going to put via again on that note. That in my pile. Alright, I think that's going to be it for me. 2 successful repairs. 1 not so successful repair. I did break this power board. What I can do for this power board actually is just take out these wires and just replace them with an actual donor board. You know, I have a little bit of time. I think I can do that right now. So a lot of these junk boards could be as easy as just like, oh, F1 fuse is bad. Or really bad water damage, liquid damage, to the point to where it's just not even worth trying to use them. That one's pretty bad. Usually when the fuse goes bad, I just don't even bother trying to replace it. Because I have so many of these power boards kicking around that I just throw it aside and just use one that has a good fuse. The ones with the buttons ripped off, I might start cannibalizing first. I've never tried replacing these buttons. But I think those are... It will definitely be something that will be fun to try and test to see what it's like to take off these buttons. Because usually I have to remove these buttons because the contacts, the actual contact points underneath, just fail. Or they just get corroded, and when you press the button, nothing happens. I'll do this one because it's missing 2 buttons and not just one. But theoretically, they should come off. Just heat them from the back, and they should pop off pretty easily. I've just never tried it. So this one still has its male connector and wire in. A little crummy, but this is the part that I want. Ooh, it's got a little bit of corrosion inside the connector. Doesn't look like that should be a problem. I'm guessing this will just brush off. A little better. Because I don't think I can pull these connectors out without like lifting that those little plastic tabs. I don't think I can do that without breaking this connector. I wonder if I can maybe just take the end of this X-Acto knife and risk cutting my finger open. Wouldn't be the first time. And then just see if I can pull out the negative, just so I can really try and clean off all that corrosion. Aha! Very good. I'm not going to be too militant with this. If it looks good enough, I'll use it. Or I'll just leave it as is. Yeah, I definitely don't have these little brass fittings or little copper fittings. So there'd be no way I could have repaired that other one. Slide the pin back in. Okay, that should be good. It's in there pretty solid. Let's get the old one off. Should probably put it in my clamp. Yeah, I'm just gonna throw them away. I might be able to reuse this male connector, but those brass fittings I probably won't be able to use. So what I kind of want to do is just soak up that solder. I think it'll be a little easier for me to pull the connectors through. Because then I can sort of set them in place and then... Oh neat, I broke my mic arm. Right on, that little fucker snapped off. Got one in. Since I have one in, I'll try and just solder to that one. And then I can worry about the positive end. I'll bolster those up a little bit. Wondering if there's a little bit of solder on the wire that's keeping it from feeding through. Yep, I think I was right. One more flux and then I'll just bolster it up. Get some good solder blobs on it. And that's what I call repaired. Huh. Well, my microarm breaking made me do something weird. I did not take off the wire off my spare, instead just swapped between two good boards. Nice. Practice makes perfect. There, now my junk board. Doesn't have a cable. Not my good board. Goodness gracious. I'm just thinking about if I can even repair my mic arm. I don't think I can. Cheap plastic that just snapped. Oh well. It was good while it lasted. I can maybe see if there's like a warranty or something, but I doubt it. Hoping there'd be enough solder there for me to just sort of lock everything in, but no, I gotta add some more. Enough to hold everything in place. Oh, that should do it. Actually, this time. Now I just gotta clean everything up. Doesn't need to be crazy. Alright, that is one power board repaired. So again, it sucks that that's just how that motherboard ended up. Just pooping out like that, or, well, me cooking it. But part of the learning process is making mistakes, and if it means sacrificing a motherboard to learn, well, essentially nothing other than that the error has occurred, could be a lot more complex depending on level of corrosion. But yeah, I'll leave it at that. There's really nothing more I can do about that board or really learn anything. I don't think I'll ever get to the bottom of what actually was the problem, but at this point it doesn't matter. I'm going to guess corrosion, but it really could be anything. So I'll call it there.